We're going to talk about buffers here, and what buffers are is it creates, for example, around, let's say with these points, a polygon of a certain distance around each type of point. Let me zoom back out. And the same idea would be a polygon around this new river file that I added. So if we created a buffer of 10,000 meters, we would actually have a polygon that would encircle both of these line features. And for 10,000 meters around each point, we would now have a polygon feature. You can buffer points, you can buffer lines, and you can go ahead and buffer polygons. There are a few different options within buffering, and I'm going to go ahead and go through a few of them here. So under Geoprocessing, we have our buffer tool, but additionally in our toolbox we have under Analysis and Proximity the same exact tool. There are a few other ones that I want to talk about in here, so I'm going to go ahead and use this one, but it's the same tool as is in here. So the first one we're going to try is our lowest geometric dimension. We have 0 dimension or point file. As we've always talked about, make sure it's going to the same file, and we want to say buff all PNTS. Oops. PNTS. Files go into the same place, and for distance, how big do we want to make this polygon buffer? I'm going to go ahead and make it, let's say, 100,000 meters, so you guys can see them, so they'll overlap, etc. So for method, we have options between planar and geodesic. Planar, excuse me, assumes a two-dimensional Cartesian plane out to infinity. It's basically completely flat, and it will measure the distance of 100,000 meters, a straight line, what's known as Euclidean distance. If we were to choose geodesic, geodesic buffers account for the actual shape of the Earth, and distance are calculated between 2 points on a curved surface, or as we've discussed before, geoid. We're going to go ahead and leave it planar just for demonstration purposes. The difference between the two is planar, we'd be using something on a smaller scale, geodesic on something like we're buffering continents or states maybe, where the curvature of the Earth actually will become a concern. For a dissolve type, the question is for each point, because we're doing points right now, do we want each point to have an individual buffer, or if we click all, do we want each point to have an individual buffer that will then be glommed on to the buffers that are around all the points? This will make more sense when I run it. For our first test, we're going to go ahead and do no, so each point will have an individual buffer of 100,000 meters. Let's go ahead and run it. And we have a giant mess. This is what each point in here has a giant buffer around of 100,000 meters around each point. If we were to run the same function, I'm going to go ahead and turn this off because it's not super helpful. That's 100,000 meters. We'll go ahead and run buffer on the same idea and just change one thing. Let's say move it to where we want to save it. Buff PNTS dissolve. Let's drop it down to 10,000 and leave this as planar for now. Dissolve type all. So before I run that, I just want you to remind you this is a mess. All of these points have individual buffers. If we go ahead and run dissolve type all, now we have individual buffers of 10,000 meters for each area. The key difference here is instead of being individual, they are now glued to each other. That is what's known as dissolve type all. Let me zoom back out. Another example, go ahead and shut that off. You could use the geoprocessing buffer this time. Input features, let's try lines. Let's see, rev buff 1. And we will give it, let's see, 10,000 was a little small, 50,000. Side type, you can go to the left or right of the lines. And end caps can be flat or rounded. This is the one I want to show you a comparison of. We'll do rounded. And let's go ahead and dissolve. Round and dissolve. We have rounded and dissolved together, so this is one full file. One file. And let me turn that off. Let's try switching it around for comparison. Do rivers again. Type 50,000, let's say 25,000 meters. End type flat. Dissolve type none is good. And let's go ahead and make sure this is going to our folder. Rev buff 2. And it should be good. End caps are flat, and as a comparison, because we chose dissolve type none, now we have two separate buffers. And just as a reminder from the last video, clear selected features. Finally, let me turn off river buffer for polygons. Let's say we choose grassland and we want to add a buffer to it. Say input features, grassland, and let's say 25,000 seems to work. Let's make sure it's always going to the right folder. Grass buff 1. Go ahead and leave side types full, fine. Dissolve shouldn't be an issue because there's only one polygon here. And let me move this below grassland so you can see it. And if we were to go ahead and see how big we made it, geoprocessing results, we made it at 25,000. Let's do a quick measurement. You see roughly 24,999, essentially 25,000 meters. Just turn this off. Finally, one other type of buffering I want to talk about is the multi-ring buffer. And what we can do here is, this is actually contained underneath the proximity tools within analysis under Arc Toolbox, is it's basically nested buffering. We click on multiple ring buffer and you can see a layout of it. At grassland center, I went ahead and calculated the geographic center of grassland, and we can punch in at different levels of distances. Let's say we want a 25,000, and then we want 75,000, and we can go ahead and do 150,000. Out to however many you want, 250. This is going to be a mess, but that'll be good. Again, different options, distance field, dissolve. Do we want them to be their own standalone, or do we want them to be hollow? Things along those lines. Let's go ahead and leave dissolve type all. Go ahead and give it a run. There you have it. Our multiple ring buffer for grassland geographic center. This may work if you're doing different iterative analyses. Let's say center of grassland, show me the points that are intersecting within 25,000, which is right here. Let me get this out. This little ring here, and then this one is 75,000, 150,000, and 250,000. You could do iterative intersects, and we could just do that real quick. Say, yeah, let's see, urban attribute table. Data export. As an example, let's say off 250,000. And then, again, geoprocessing, selection, select by location. From the last video, we were doing select by location. Select from all points. Those points that might intersect. Let's see, where are you? Buff 250,000. Intersect. We don't need a search radius this time. Go ahead and apply. Now we just have the points that are within that area of the buffer at 250,000 meters. Go ahead and close, and as always, selection and clear selected features. We don't need these guys. Go ahead and turn them off. We don't need grassland center. Alright, one final bit I want to talk about are Thiessen polygons. And Thiessen polygons are generated. There are a certain type of polygon that are generated from a set of sample points. Let's say we've got all points here. It could be airports, cities. We have a map for intermediate GIS where we use Major League Baseball team locations. But from this set of sample points, these polygons are generated such that each polygon defines an area of influence around its sample point, so that any location inside the polygon is closer to that point than any other sample points. Let me go ahead and create it. And we've got, let's see, the all points file. Make sure our output is PNTS Thiessen 1. In our output field, which ones do you want to preserve? Moving to the Thiessen polygons, generally you probably want all of them. We'll go ahead and hit OK. This might take a little bit. So what we have here are, let me see if I can change the color. That's not color properties. Symbology, let's see, values on ID and values. ID. It's fine. Let me zoom in on one in particular. How about these guys? So for this particular polygon as a sample point or whatever, the area underneath this polygon, all of it is closest to this point. Same one for here. Everything underneath this polygon is closest to this point. What these are commonly used for are, if you are flying in an aircraft, for example, let's say you take off from this airport and you need to fly over here. While you are flying along, when you enter this polygon, you make a note that if there's an emergency, this is the closest airport to land at. And moving past this line, now you are, emergency airport is here. Same idea moving forward. You went ahead and crossed here. It'd actually be shorter to get to here and here, all the way to your destination. Other uses for this let me zoom back out. If these were rain gauges, one of the methods used for rain gauges is, let's say we have these guys up here. The sample from this rain gauge is considered to be the sample for this area polygon. Thereby, if you have an area covered in rain gauges, like here, the entire area is sampled even though you only have a point file. That is it for buffering and Thiessen polygons. In our next video, we will talk about spatial joins. Thanks.